Okay, we're picking up on Math 31 notes for section 13.1. This is the third installment. And this is a similar section to what we had on the last video. The difference on this first problem here is that instead of just having x values fed to us, we have to pay attention because sometimes we're fed the y values. Okay, so let's start by plugging in a y value of 9, and doing so leads us to negative 8 for the x. So you go 8 to the left and 9 up, and there's your first point. And then you plug in an x value of 4. So we're going to do that next. And the calculations, when you put in x equals 4, leads you to a y value of 0. So 4, 0 is on the graph right there. And the next one we're going to plug in here is x equals 0. It's pretty convenient to plug x equals 0 in. You can follow all those calculations if you want to, but it gives us a y value of 3. And 0, 3 is right on the path. We're doing good. And then finally, the last two calculations, or the last calculation here, I skipped all the stuff in the middle, but when you plug in a y value of negative 3, it yields an x value of 8. So that would be 8 to the right and 3 down, and everything's lining up like it should. So maybe I need to do this a little more carefully. Last time I messed up. Okay, there's the line that equation represents. You want to indicate that it goes forever by putting arrowheads. All right, another example of this. I'm going to go rather quickly through here. First time around, we're going to use an x value of 9. And there's the calculations. I'll go through them with you once. When you put an x value of negative 9 in, you get negative 4 times negative 9 is negative 36. You're going to add that to the other side or both sides, and you get 48 over there. And dividing by negative 6 gives your answer. Okay, the next one we're going to do is, let me go ahead and put that in, negative 8. So this is 9 to the left and 8 down. Negative 9, negative 8. Okay, then we have our next one here. We're going to use a 2 for the y value. And doing so gives us a 6 for the x. So that'll be 6, 2. When you use a 0 for the x, you get negative 2. 0, negative 2. Lining up pretty good. And putting in negative 4 for the y gives you a negative 3 for the x. So 3 back and 4 down. And those are lining up beautifully. Okay, these are linear equations. They should always line up, since you need a line to go through them all. If that doesn't happen, it's kind of a self-checking thing. It'll let you know, screams at you, you're not doing this right. Okay, this example comes from the textbook, and you're going to be doing one similar to this on your homework. It says the average cinema or movie admission price, Y, in dollars, from the year 2007 to 2016 is given by the formula. Here's the formula we're going to be using. And the first time we're going to use an x value of 2, and it says in the problem that x represents the number of years after 2007. So 2 years after 2007. That's actually 2009 prices that we're calculating. And when you put that in, you get $7.43 admission price. All right, the next x value is 5, and that would be $7.94. Price of a movie ticket's going up. And then we look at the last calculation here. 8 years later, that is 8 years after the initial 2007, we're dealing with a price of $8.45 average for a movie admission. I personally think these numbers are a little bit low, but maybe the data is old. Okay, find the year in which the average cinema price or movie price will be $8. Well, this time it's the Y that they give you. The Y is 8. So let me explain how I got these calculations done. The first thing I did is subtracted 709 off both sides, and then divide both sides by 0.17, and I get 5.35. Now that's not dollars. Those are years, so I have to say, well, interpret that as 2007 plus approximately 5, we round to the nearest whole number, is about 2012. So the average price we would guess from this formula would be $8 in 2012. Okay, that last one is the same thing with just different numbers. You first plug in your 10 as your Y. You can see I did that. To counteract the plus 7.09, I subtracted off both sides. That's how I got this 291. That's 10 minus the 7.09. Divide both sides by 0.07 so that they cancel off this side on the right. And you get 17.12. This isn't a year, so we're going to round to the nearest whole year, which would be 17 years added to the 2007 figure gives a year of 2024. So this is in the future, and it doesn't look very good for moviegoers. Up to $17 a ticket if the trend continues. I'm not sure the trend has continued. The first year was 2007 before the recession, and I think it took a dent. It's not linear. Prices go up and down depending on supply and demand. Okay, this concludes the videos for Notes 13.1.